Let's do some with significance tests for slope now. And again, the standardized test statistic is going to be the statistic minus the parameter, the standard deviation. And so in this case, the statistic is B. The parameter minus the parameter is the hypothesized slope. And then the standard error of B is on the bottom. And of course, if you find a t, then you're finding the probability under the curve for the t value to be either less than, greater than, or not equal to a value that you're finding here, that you get here. And we actually never did this by hand, but there isn't, just so that I cover it at least once. Because we're going to do the test using the function, we don't really do this by hand, but you could do the test statistic t. You're finding the area under the curve for a t distribution is TCDF instead of normal CDF. And the rules still similar and apply, so you could potentially do it that way. But again, we're going to use the graphing calculator function, so I'll start on this question. Infants who cry easily may be more easily stimulated than others. This may be a sign of higher IQ. Child development researchers explored the relationship between the crying of infants 4 to 10 days old and their later IQ test scores. A snap of a rubber band on the sole of their foot caused the infants to cry. This seems pretty brutal. They used to be able to do some crazy experiments way more in the past. I don't know if this would fly today, but plus the obsession with IQ scores. Anyway, so the researchers recorded the crying and measured its intensity by the number of peaks in the most active 20 seconds. They later measured the children's IQ at age 3 years using the Stanford Binet IQ test. And the table contains data from a random sample of 38 infants. The problem with this question was that I forgot to copy and paste the question, the actual question, which was frustrating for me to say the least. But the actual question is, and you might have to add this to your notes if I printed this out for you in 2025, but I'm hoping to add it for next year. So do these data provide convincing evidence at the alpha equals 0.05 significance level of a positive linear relationship between count of crying peaks and IQ in the population of infants? All right, so here is our data, and here is the regression analysis. Before you type anything in, stop, pause. This one is like just not necessary at all. This is super easy because everything here is given to you. So you might not get computer output. In that case, you might not even get any of this. You could find all of this using the data here. You can find the regression line by looking at the slope and the y-intercept using the linreg function that we have, etc. But, what I'm trying to say is don't blindly start typing numbers in. Okay, so let's just start first, and then when we get to the point where we have to make a decision whether we're typing numbers in or not, then we'll cross that road. So state, we want to test that the null hypothesis that slope is 0, so no relationship between the two. Slope is 0. Whereas the alternative is that there is a positive relationship. If there's a positive relationship between the two, then that is the correlation is positive. That means the slope is positive, so greater than 0. Where B is the true slope of the population regression line relating y equals IQ scores to the x count of crying peaks in the population of infants. And when we plan this out, this is a t-test for the slope, not a t-interval, but a t-test because it's a hypothesis test. The conditions are the same, OMG. So linear, yes, the scatter plot shows a linear pattern. relationship between crying peaks and IQ, and there are no leftover obvious patterns on the residual plot. No obvious patterns left over on the residual plot. Independent, n is greater than or equal to 10 times 38, which is 380. Yes, there are at least 380 infants. I mean, is there ever? And normal, the histogram of the residual plot, residuals, not residual plot, but the residuals histogram show no strong skewness or obvious outliers. Equal SD, the residual plot shows a fairly equal. Notice that they're not saying very, because like this is farther from here than the rest, but a fairly equal amount of scatter around the horizontal line at 0 for all x values. Yes, sample selected randomly. And degrees of freedom, there's 38 infants that they selected, minus 2, 36. T is 3 point, the T score is, and this is not T star. T star is for confidence intervals. This is the T score for your T distribution. It's kind of like a Z score, so probably not there, more like, let's do this again, somewhere out here, 3.07, the T score, okay? And yes, remember, T distributions look like normal distributions, but they have fatter tails. They tend to have fatter tails. Regardless, it's the T score is 3.07. Where did I get that? Hey, I got that from the output. It states it right here. It's so awesome. This is your T score. T score, the test statistic. Okay, and then this is your P value. It just says P here, but it's the P value, 0.004. The problem is, there's not a problem actually, but this is for not equal to scenario. This is for the not equal to scenario. Whoops, I can't spell it. There. And so we would have to take half of that, which is super easy to do. So T score is 3.07. P value is 0.004 divided by 2 equals 0.002. Since P value is 0.002 less than alpha is 0.05, we reject the null. There is convincing evidence of a positive linear relationship between count of crying peaks and IQ score in the population of infants. Here's another example. Pause your video here, try it out, and check your answer. I love this question because it says to assume that the conditions are met, which is amazing. So as you notice, if they do that on a test, it would be awesome. But then you would just put your plan section and you would have two things. You would have your t-test for slope, and then you would just say conditions are met per question or something like that. So pause your video here again and attempt this problem and answer your questions. And this requires you to remember the type of errors, type 1 versus type 2, from a previous lesson we've learned. And you are done.